from Just Tutors, and today we will learn about matter in our surroundings. So, can matter change its state? Effect of change of pressure and temperature. These are the points we will learn today. Yes, matter can change its state, and good example is ice can be changed into water, and water can be changed into gas, which is vapor. So there are two factors which are responsible for state change. First is temperature and the other is pressure. Now, how temperature affects the change of state. So on heating, the temperature of matter, in this case we can take example of solid. So the temperature of solid increases, due to which the particles kinetic energy, or the kinetic energy of the particles, increases. As the kinetic energy increases, they start vibrating at great speed, and the motion of particle increases, and the certain point comes when they leave their position and start moving freely. So at that point the solid will change its state to liquid, and if we heat it further, then the liquid will be converted into gases. So the heat given is used to overcome the force of attraction. Here we can see, as we give more and more energy, the force of attraction which is higher here will be lesser here, and then in this that will be least. So that heat is used to overcome the force of attraction between the particles. Now, how temperature affects the change of state. So generally on heating, temperature increases, but during the state transformation, the particular point at which the particular temperature at which the state is transforming, the temperature remains same, because the heat which is given to increase the temperature is used to overcome the force of attraction between the particles. So the point, the temperature at which solid changes its state to liquid at atmospheric pressure is called melting point, and the melting point of water is 273 Kelvin. This is different for different substances. Higher the melting point, higher the force of attraction between the particles. Yeah, this is right. Actually, if the higher the force of attraction, then we'll have to give more and more heat. So the temperature would be higher. That's why melting point is higher in case of higher force of attraction. Now, boiling point. So we all have boiled water. So when we give heat to the water, or we put water kettle on the gas burner, the particle starts moving more freely, and the certain point will come when the particle will have enough energy. Now the liquids start converting into gases, and we can sense the vapor. What happens, actually, the particle gets enough energy to overcome the force of attraction between each other, and at this temperature water changes its state to vapor, and the temperature at which the liquid starts to boil at atmospheric pressure is called boiling point, and in case of water it is 373 degree Kelvin. Now, how temperature affects change of state. Again, the same thing we are studying. The another point is freezing point. So it is the temperature at which liquid changes into solid. We have discussed the melting point, in which the solid changes to liquid. Now the freezing point, opposite, at which liquid changes its state to solid. So when liquids are cold, means the temperature decreases. When the liquids are cooled, they become solid, and at particular point at which the liquid changes its state to solid is called freezing point. The freezing point of water is 273 Kelvin. At this temperature, it is converted, we are talking about water, the water is converted into ice. Remember, that is the same temperature which was the melting point of ice. At this temperature, we have both water and ice. Now, we will discuss about latent heat. So, latent heat is a heat required for substance to change its state. So first is latent heat of fusion, the amount of heat required to change 1 kilogram of solid at its melting point to liquid at atmospheric pressure. And we discussed that when we increase the heat at the point in which the temperature doesn't change but the state change. So where does that heat go if the temperature is not changing? That heat is converting the state. So the water, if we talk about fusion, the ice is converted into liquid, so that excess heat is converting into the energy, and at that particular temperature the water has more energy than the particles of ice at the same temperature. In the same way, we have latent heat of vaporization, amount of heat required to change 1 kilogram of liquid at its boiling point, at boiling point to gas at atmospheric pressure. The particle of steam at 373 Kelvin or 100 degrees Celsius have more energy than water at same temperature. The excess heat is used to change the state. We have discussed that. Now let's move on. Sublimation. It is the process in which solid changes directly into gas. There are many substances which changes directly from solid to gas, and these substances are called sublime. For example, naphthalene balls, dry ice, ammonium chloride. So there are so many substances we can see in our daily life. They don't convert into liquid, they directly convert into gas. Now, effect of pressure on change of state. Well, the difference between the different state is because of the space between the particles. Normally solid and liquid does not have any effect on pressure because solid does not have space between the particles, and so you cannot compress the solids, and liquid have very less space, so liquid can be compressed only to little extent, but gases can be compressed easily as they have lots of space between their particles. So if we compress the gases, that can be converted into liquid. And we have very good example of LPG and CNG, liquefied petroleum gas. So if we compress the petroleum gas, that will be converted into liquid petroleum gas. And compressed natural gas, these we get by high pressure. Now let's see what did we learn. So you can pause the video, try these questions. I hope your answers are correct, and thanks for watching this video. For more, you can visit justtutors.com. Thank you.